Properties of vector cross product, that's the topic of this video. But before we go into that, let's just have a short introduction to what is vector cross product. So this vector product, which is vector cross product of any two non-zero vectors a and b, is written as a cross product with b and is defined as a cross product with b is equal to magnitude of a into magnitude of b into sine theta n cap, where our theta is the angle between the two vectors a and b, and the angle is normally between 0 to pi, and vector a, vector b and the vector n cap form a right-handed system. For a more detailed understanding of this right-handed system, you can listen to the video which is in the description box. The link is on the description box that has a very detailed description of vector cross product. Further, the magnitude of vector A cross product with B is defined as the area of the parallelogram whose adjacent sides are A and B. So that's the parallelogram whose adjacent sides are A and B. So the area of the parallelogram is the magnitude of the cross product of vector A and B. Let's move on to the properties of vector cross product. Now, by definition, B cross product with A can be defined as magnitude of B into magnitude of A into sine theta into minus of n cap, because this is B, this is A, and if your n cap is in this direction, then our resultant vector B minus B cross product with A will be in the minus n direction. So they form a right hand system. So further, you can rewrite this as minus of magnitude of A into magnitude of B into sine theta into n cap, which is nothing but minus of the A cross product with B. So you can clearly see that B cross product with A is not equal to A into B, but rather it is minus of A into cross product with B. So they are not commutative. Next, if two vectors are collinear or parallel, then A vector cross product with B is equal to 0 vector. How can we explain this? See, when they are parallel, that means vector A and vector B are parallel to each other. So the resultant angle between the two vectors theta is equal to 0. So when theta is 0, your sine 0 will become 0. Therefore, your A cross product with B will be equal to 0. So further we can infer that if we have A cross product with B as a 0 vector, it could either mean A is 0 or B is 0, or A and B are parallel. So we can further say for any two non-zero vectors A and B that our A cross product with B is equal to 0 would imply that A and B are parallel. We know that if the cross product is equal to 0, these are the three options. But here we eliminate these two options by saying that it's a non-zero vectors. So A and B are parallel. Further, we can say that A cross product with A will be always 0 vector. The next property is, with the usual meaning of I cap, j cap and k cap, they form a right-handed system. The following results are obtained. It is clear that I cap cross product with I cap is equal to j with j and k with k is equal to 0, as we have seen in the previous property. Further, we can derive that I cap cross product with j cap is equal to k cap. Why? We know that they are all orthogonal vectors. Similarly, j and k will form I and k and I will form j. Further, we can say that j cap cross product with I cap will be equal to minus k cap. Logically, the line of action will be in the opposite direction, and algebraically you can say that since we have I cap, j cap is equal to k cap, when you reverse them, you know that it is minus k cap. So same way you get all these three results. If our theta is equal to pi by 2, then our A cross product with B will be equal to magnitude of A into magnitude of B into n cap. Why? Because our sine theta would be sine pi by 2 and sine pi by 2 is 1. Therefore, you get this result. Property 6. For any scalars m and n, we can, if we have ma vector into cross product with nb vector, you can rewrite it as mn into a cross product with b, or mn a vector cross product with b vector, or it can be written as a cross product with m and b vector, or it can also be written as n a vector cross product with mb vector. Further, a vector product cross product is distributive over addition. So if you have a cross product with b plus c, it can be rewritten as a cross product with b plus a cross product with c. Similarly, a plus b cross product with c can be written as a cross product with c plus b cross product with c. This property can be extended to subtraction and to any number of vectors. That is, a cross product with b minus c is equal to a cross product with b minus of a cross product with c. Similarly, if you have three vectors b, c and d, then a cross product with b plus c plus d would be equal to a cross product with b plus a cross product with c plus a cross product with d. The next aspect is a very useful one in calculating a cross product with b. If you are given the two position vectors, then a cross product with b can be defined using our distributive law. As you expand, you get this, and we know that I cross product with I will be 0. Similarly, j with j will be 0, and k and k will be 0. And further, we know that our I and j would form k, and I and k would form j. So rearranging them all, you would get it as a2 b3 minus a3 b2 I cap, and so on, which is nothing but the determinant of the matrix I, j, k, a1, a2, a3, and b1, b2, and b3. So when you are asked to calculate the vector a cross product with b, and you're given the vectors as position vectors, then this would be your resultant vector. Further, we can extend the cross product to find the angle between the two vectors. So if theta is the angle between a and b, then theta is equal to sine inverse of the cross product magnitude of a with b divided by a magnitude vector multiplied by the magnitude of b vector. The last property that we would see in this video is the unit vector perpendicular to both a and b, or plus or minus n cap, which is equal to plus or minus of a cross product with b divided with the magnitude of a cross product with b. Extending this to vectors of magnitude lambda perpendicular to both a and b, it can be written as plus or minus lambda n cap is equal to plus or minus lambda a cross product with b divided by magnitude of a cross product with b.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.